Welcome back, pre-calcers, to P4, dealing with polynomials. The objectives here are as follows. Seems like a lot with some complex vocab, but that's nothing we can't handle. We'll understand the vocabulary of polynomials, dealing with, just exponents, variables, which are usually x. So as an example, probably see x or y. I think it's mostly y and x in here, but yeah, sometimes that letter switches up. We'll see polynomials with multiplying, and then that also ties into using the FOIL process to take it further and rewrite what the product of these polynomials can be, using special products and polynomial multiplication. So difference of squares is a pretty common one. We'll also see terms being cubed, and we'll also perform operations on polynomials with several variables. So the main thing here with these examples is eyeing up a few things. So you always want to check and see what exponents you're working with. Are you working with exponents of 2, exponents of 3? And then what variables you're working with. So are you working with just x, just y, or is it a combination of the two? Because you might end up with xy, which can happen. So when I look at problems like this, I know that I have this polynomial, which is just a lot of terms thrown together, adding with parentheses around this polynomial, subtracting everything in this polynomial. And it seems a little complex, but you try to rewrite what you can. So this is similar to in P1, where we were rewriting algebraic expressions. So I know that I'm just going to be adding these two, which I could do right off the bat. I personally try to go ahead first into where I think it's going to be the most difficult term to rewrite. So I know that I'm subtracting this entire polynomial. So I'm subtracting everything that's here, which may seem intimidating, but that's nothing we can't handle. So let's get some extra paper. I'm gonna change everything in here. So I know that if I'm subtracting negative 4y cubed, that's really just adding on 4y cubed, and then deducting 5y squared, and then adding 7. So what I did here was just rewrite this because I like working with positive terms. That makes my life easier. If I rewrite the beginning portions, I'm now going to drop the parentheses because these are just adding on, and I think it's easier to just start to combine what you can. So this seems like a lot. So let's work on this from left to right, trying to combine what we can. So I see a y squared term, and I'll color coordinate for this. I see y squared here. Do I have any other y squared terms? What do you think? Oh yeah, we got 2 y squared terms. Seen here, seen here. So if we focus on combining those, 5y squared plus 2y squared, deducting 5y squared, pretty much 5 plus 2 minus 5 just gets you 2y squared. So we dealt with that. We then have 6y. So if we get this, do we have any other y terms? We sure do. 6y minus 5y is going to just add on y. We then have just constants of negative 3 and 7, so we'll combine those. So I have a constant here, constant here. Be careful with the terms. If they're negative, hold on to that idea that they're negative. So we're adding on 4. And then are there any terms left over that we haven't talked about? Oh yeah, this little lonely one over here. Add on 4y cubed. There's nothing else we can combine. If you want to aim for standard form, which is just the highest exponent going down to the right, we can rewrite this as 4y cubed plus 2y squared plus y plus quattro. That would be the most simplified version of this. Cool. Next one. So we are now multiplying with everything that's here, and this can get a little complex. Previously in Algebra 2, you might have learned about foiling. The way that I approach situations like this with multiplying is with box method. So what does that look like? We're still going to be multiplying this 5x squared y plus 2x with this second term. But the way that I set up the work is going to look like this, where I have, one of the polynomials up top using a good amount of space, and then on the side, writing the rest. And a box below it so that each term has its own column and its own little row. So what happens here is that I multiply everything in each box. So here, 5 times 5 gets 25. X squared times x squared gets us x to what power? If I'm just focusing on x squared times x squared. 2 plus 2 gets you 4. Moving along, 5 times 2 gets you 10. Add your exponents, imaginary 1 on that, so x cubed and y. We are then deducting 2 times 5, which is 10, x cubed, y is along for the ride, and then finally 2x times negative 2x, negative 4x squared. And so once you've filled this out, again, this is called box method. There are some other methods or other names for this approach, but I like the box one. I think it works well. So from here, it's a matter of combining what you can. So we can try and match up any like variables, any variables that, or any terms that have the same variable, same exponent. So look it over. Do you see any consistent patterns with terms in there? Hopefully you're noticing that these two terms on the diagonal can be combined, and these actually cancel because it's 10 x cubed y minus 10 x cubed y, so those cancel. And all we can really write left over is 25 x to the 4th y squared minus 4x squared. Where I see students trip up here is that they'll try and combine this, but you really can't because these variables are different. Although this is x squared and this is x to the 4th, you can't combine them any further. So we just hold on to that. With the next bit, although this looks complex with parentheses around 2y minus 5 being cubed, you're allowed to break this up a little bit and just say that this is 2y minus 5, 2y minus 5, which you could easily do with box method. So if you want to do that on the side, go for it. I'll leave that up to you. I'll fill this in a second. And then remember, this is cubed, so this is all multiplying by itself 3 times. So I first will focus on the first two terms being squared. So this will get you 4y squared minus 10y, positive 25. So I can rewrite this to 4y squared minus 20y plus 25. And so again, this is just the product for these first two terms. We still have this third one to focus on. And the box method for this will look a little different, slightly modified. So let's keep these 3 terms up here, so make 3 columns. And we have 2 terms left over with this 2y minus 5, so let's do 2 rows. If we multiply away, this is going to be 8y cubed. Subtract 40y squared, 50y minus 125. I'm kind of hopping around. I hope all of my arithmetic's right. And then finally deducting this 20y squared. And so once you fill in all of the boxes, think, can you combine anything else? Let me just reiterate, this was the third 2y minus 5. Is there anything we can combine from this box here? Hopefully you see that we have y squared terms we can combine, and also y terms we can combine. So from left to right, let's call this 8y cubed, leading this, subtracting 60y squared. adding on 150y minus 125. Nothing else we can combine, so we're done. It may seem as if it's pretty extensive to combine everything here, but that is how we can do it. Just break it apart, make it easy on yourself. Don't stress it. You got this. Thanks for watching. If you have any questions, bring them to class, and I'll see you in the next video.